inside of the tin is rusted. Okay, dokily. So what we got here is an old school Texas Star. This is an old school Texas Star tx500. It's kind of a white blue face label. It's about as old as I am. It has seen better days. I just want everybody to be able to drink in the whole glory of this situation. Yeah. To just suckle it in. All the way in. It has been burned up quite a few times. Like, quite a few times. We're missing our you know, we got this going on for our sideband cap. That's huge, man. Oh, there's just so much going on. But the main thing is it's really, really dirty. The other thing is the transistors are completely wiped out in this thing. If I remember when I tested this thing before, you know, I should do this now. I tested this way back in the day. And I should do that just, you know, like right now. Let's do that right now. Here. Grab my drill gun. We're going to make this happen. So my friend owned this amp, or owns this amp, right? And, I mean, this is my guy. This is one of my dudes. This is one of my really close friends. We call him Cue Ball. And, okay, it didn't catch on fire as soon as I put positive current to it. That's good. Cue Ball here drugged this thing up here and dropped it off about 1.5 years ago. And it got lost in the menagerie of stuff, you know, because he used the famous words that you never want to use with an amplifier technician. Don't worry, I'm not in any rush. You fix it when you have free time. And that meant, oh, okay, I'll think about it once you decide to ask me about it. That's how it translates in an amp builder's mind, by the way. It got set in a pile over there. Whole year goes by. He calls me up and says, hey man, can you take a look at it? I said, sure. So I took a quick look at this thing. It had a lot of problems. I'm not gonna lie. And I told him, I said, man, I think it's got, you know, like 3 pop pills in it. And it just looks like it got hit by a hooker walking down the road with a sledgehammer, you know, and smacked with the ugly stick all the way out the tree. I said, man, I don't know. You're going to spend quite a bit of money for me to put this thing back right. He's like, don't worry about it. Just throw it away. I don't throw amps away. I looked at it and went, okay. Put the tin back on it and set it on the shelf. Now here we are 18 months later-ish. 12 months later, whatever. He called me up and he goes, hey man. Oh, yo, bro. He goes, you got a Texas Star I had with you? And I'm like, yeah. So I wasn't thinking. I should have been thinking. I should have said, yeah, man, you told me to scrap that thing. Remember, I scrapped it for parts. Don't even have it no more. He's like, but that's not the way I roll. Not the way I work. I said, yeah, man. He goes, yeah, let's go ahead. Let's get that rebuild. I want to get it done. Oh. We're not going to point out the fact that this whole corner of the amp right here by the relay has been on fire at one point or another. Okay. So he doesn't know this is coming. He's not going to even have a clue that this is happening. I'm doing this video now. You guys are going to get to see it in a week or so from now. Yeah, so I'm going to hang out with him here in just like a week or so. I literally walk up to him and be like, here's your amp. And it'll be all completely rebuilt with a fan on it. So, let's see, imaging mode, thermal and picture, no, thermal, mixed. Let's do thermal and picture. Okay. See how big the hill is that we got to go climb here. It's power. Power light works. Oop, preamp light. least the preamp works. But we're going to give them a transistor upgrade. Okay, so off. Hello, 1 2 1 2. Hello, 1 2. All right, so we can talk through the amp, through it. RF can go in, come out. That's good. Hello, audio. Okay. Amplifier, no key. Hello, 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 hello. Let's do this a manual, old school. Hello, amp is keyed now. Hello. Hello, audio. Hello, audio. Nothing going in. I got burnt 10 ohm. Got a burnt, pardon me, burnt resistor here, burnt resistor here. Transistors are not working at all. Hello, and I'm seeing an infinite input SWR, infinite. Driver is not even heating up. Hello, audio. Hello, audio. Hello, audio. So, needless to say, there are a lot of problems. Preamp's working. Amp no key. We've got no input whatsoever. So that means we got to bust out the O-scope and we got to start tracing down where we're losing the RF, or if it's just going to ground in the driver. Because personally, what I think has happened here is that this amp has been hooked up backwards. That's just me. So I'd have to assume that all these transistors in here are bad. But we're going to find out. The very first thing we're going to do is we're going to strip out this old bunk-ass power wire, and then we're going to go wash this thing. So let's let this just get breathed in how nasty this is, which is no big deal. And let's go clean all the dirt off of this thing, and let's see seriously what we've got for fried parts and where we're losing our ground, or losing our RF on the input side. But first, after we wash it, we've got to figure out why the key-in circuit's not working. Then we'll go from there. Okay, so we have seen this kind of setup before, where something goes awry, either in the bias, or the transistors go bad, or it finds a short in the bias circuit, and this whole corner of the board gets decimated. So let me grab my voltmeter here. I want to show you what we're up against here. The whole amp is full of technology like this. It's been one cobbled together repair after another when it comes to this hot dumpster fire here. I mean, I talk about electrical sin bins from time to time, but this is a good one. Okay, so we got the amp plugged in, and the amp is on. You wouldn't know it because of all the other shit that's broken. And anywho, I should be able to probe right here with the voltmeter and have a switched 12-volt source. Should be able to turn that button on and off and have 12-volt electrical pixies hit that connection. I don't have it. Another thing I should be able to do is probe here. And I got 12 volt switched here. See this? So there's a trace that goes from this pin down here, crossed, goes back over, goes through the switch, comes back out, runs across, dives under the board, and runs over here to the corner. Well, we know that trace is borked as fuck, because if they've got it already replaced with a piece of solid wire, which we're going to have to come back and replace to bring it up to standard. This is all solid wire. That's all got to get replaced. But the main thing is we just want to see if the effing pills work, right? So I am not going to take the board off this amp. I'm not going to. It takes like 2.5 hours just to get it down to where I can disassemble it. And no. So just to do the test, we're going to go ahead and we're going to jumper from our switch 12 volt source here to our what would be switched here. So anyhow, it dips down and it runs across and it pops back up and comes back around and eventually runs over to the relay, is what I'm getting at. Somewhere in that menagerie of 15 passes through solder vias, we've lost our 12 volt reference here. Now the 12 volt hits the relay, it gets switched through the relay, comes back over here through this choke, but also over here in the choke, this choke here, the trace takes off, and that's what runs our grain of wheat light bulb that lights up our transmit indicator light. Okay, so when I can move this right here, move the relay, and I'm not getting any actual key up, that's telling me that the entire bias circuit is not getting fed by 12 volts. And the long and the short of the story is, even without a voltmeter, if that light is not kicking on and you manually move that relay, you know that you've got a problem in that trace circuit. So our 12 volt comes in, pops up here on this pin. Push our switch on, travels down this next pin, through the board, over, and then it energizes the rest of the rail. Okay? Well, when you push that switch in, it conducts it to the second pin. So then it comes in, it hits this pin, comes across this lead, and there's a trace that takes off and comes back over here to this leg. But then the trace continues, and it comes to these solder vias that are right here at the front. The solder via passes down, it comes along this trace, comes along to this solder via. That transfers over to our primary bus bar. That's how the 12 volt gets in. So the saying that this trace is borked, I have a pretty sneaking suspicion there's some other burn up traces underneath. But if I put RF to this and this lights, then I know what I got to do. I can either just run a wire over to here from a switch. It doesn't matter where the switch 12 volt source comes from. It's just got to have it. Okay. Cheddar. Look at that. Cheddar. Now before we go any further, let's go ahead and let's latch onto the front end of the input transformer on the 4-pil section here. Hello. Oh, yeah, we're Houston, we got problems, like big ones. Let's go look at this one over here. That one's still correct. There's a serious leakage in the circuit here, and it's probably coming from one of the transistors. But we wanted to look at that before we got any further. Let's go look at the input transformer on the driver. It's borked up too. These two circuits are tied together right down here. So we know this circuit's whacked as frig, but I can guarantee you, with the voltage being over a volt present, there's too much current. These transistors here are definitely gone, and so's the driver. So there in turn we can go, well, I'm putting in power. Hello, 1 2 1 2 1 2. That's the amplifier keyed. Let's take the amplifier out of line. Hello, 1 2 1 2. So where's our power going? $64 million question. Where's the power going? Hello, 1 2 1 2. There's a reason that I've got this bench 2950 turned down so friggin' stinking low. Only does like 20 watts. This is a dual MOSFET radio, right? 20 watts. Because when you start to crank that thing up, the MOSFETs get real delicate. There's a reason that I've got a dual MOSFET radio as my primary bench radio that I have tuned way down. So I can sit here and I can key it many times into high SWRs and not totally fry out the finals. Okay, so now what we've done is we've hooked up our oscilloscope. Hold on, slow down. Walk everybody through your train of thought. This is where our RF comes out after we get done playing with it and moving it through all of its attenuator pads and everything. The RF comes out here, and normally it would jump over to a variable. But since this is a 500, it's going to go past another set of resistors, I don't know why they couldn't just get their input circuit right instead of having to bury it behind 1, 2, 3, 4, 5, 6 resistors. Now I understand that a couple of these other resistors represent the AM and what I consider to be medium and low settings for the AM and then sideband delay. But I mean, really, this, by the time you could have the proper input ratio. Like if I was to bypass all this resistor bullshit here, the input on this one pill section is deplorable. I mean, deplorable. I don't know if the engineers designed it that way to protect, I don't know. All I know is the output circuitry here is missing its 1000 puff. There shouldn't even be a capacitor on this side over here. There's so much that's wrong here in the driver's section. I know this has been fried and somebody's taken this apart. I get to completely rebuild that. But what we're doing is we're just wanting to see, now we're testing out the portion of the circuit to make sure that the RF is coming in the box, magically making it through past all this burned up shit, through the relay, past our input attenuator, through all the different switches and traces and stuff, and making it to here, the input section of the one pill. Okay? Let's zip over here to our oscilloscope. So the yellow line on the oscilloscope is my coupler. This here is the coupler from the line section that we've all looked at. This blue line is the probe. We're currently got the blue line. Let's turn our voltage down a little bit. Otherwise increasing the sensitivity. Oh, 1, 2, 1, 2, 1, 2, 1, 2. Okay, so what this one simple test is telling us is that the RF is making it from the coax connector through the old school coax, through this burned up Hibmid jobby mess, through the relay, up through the switch bank, and is trying to go into the one pill driver section. Now, I can do this with relative safety. Let's make sure I got my probe on 10x. I know I do. The output section of the one pill comes to this trace right here. This trace in turn hooks around and it comes to this splitter. So we're going to probe at the splitter, and let's repeat this process. We got nothing. That tells me the driver section's popped. There's just a lot of stuff wrong here. I mean, a lot. So the voltmeter measuring the bias voltage told me that these two transistors are going to be popped, and so is the driver. I just wanted to prove it on video, other than holding the flare up going, oh, look, it's not, the transistor's not heating up. This is the lazy man's tool right here. Look, click, transistors aren't lighting up. No go on transistor yo-yo. This thing is a mess. Okay, so now I know what I got to do. This is, I call this reading the tea leaves. The amplifier's telling you the story. It says, hey, I'm broke. This is where I'm broke at. This is what happened. This is how I broke. Do you want to take this on as a repair? And normally I would say no. We would probably relegate this poor girl to the parts bin. But like I was saying, I want to surprise my buddy. And he's been a good friend of mine. I mean, literally, I call him. It's like, yes, whatever you need. No problem, bro. We got you. So, deserves you a little kickback love. But in the same breath, he's relegated this thing to the dumpster twice. Yeah, it wasn't until he found out I was coming through his neck of the woods where he's like, can you fix it for me? So, we'll do our best. We'll do our best. Let's go ahead and let's violently disconnect these old power wires. Let's go ahead and disconnect our coax. And let the chop shoppery begin. We washed this before I shot the last segment. I'm going to have to wash it again. I just Had to wash it just to get through all the schmoo that was in it. So we got all the transistors out, and I've got them sitting here nice and neatly organized for us right here. So they had a Motorola SRF 2072 driving 4 MRF 454s, big bodies. Motorola classics, not the Maycom Chinese knockoffs. So, God, back when they cared and they'd gold plate the foot and stuff. No one cares anything about the transistors they produce anymore, or the data sheets associated with them. These are the three that were, yeah, short, dead short junk. This is the driver, and this is the other two that were associated with the driver circuit. So we know these are junk. The only ones that might even work are those. Junk. Okay, diode short. I love when people try to give me crap about this little tester. Dude, you show me any other tester on the market that is better than this one in this price range. And that is the key in this price range. There are way, way, way better testers than this one. Like, not even a comparison. Also junk. But for the price point that this is at, which the normal human can afford, there's nothing on the market like it. That and its little brother, the Atlas DC55. There's nothing in the world that can come close in this price point that does everything that this does. It's a curve trace machine. This is a little bit of a load tester. You can change the voltage on the curve tracer up and down from 12 volts all the way down to like 1. I mean, there's, for what this is at its price point, there is nothing. And I laugh, man. I get in some of these groups, and these guys, they get all technical about everything. That's going to cause it to read falsely. There's a little solder flake going on here. Let's get rid of that. Look at my, well, Atlas is a piece of shit. It's not very accurate. Yeah, compared to a $4,000 transistor tester, it's not very accurate. No component detected. Let's try this again. Compared to the Tektronix curve trace I have, which is huge, the size of a fucking huge. It's like the size of a little welder. Yeah, not the greatest in the world. As far as the HFE gains off by, well, depending if you load the transistor or not under current. We don't need that for the general quick burn repair. This has got an HFE of 3, so it's got one transistor in it. That's good. So that's great. That tells me that the thing wasn't hooked up backwards. Otherwise, it pops all the transistors. So, all right, cue ball. Your dirty old musty bitch has got one transistor in it. So that's good. Okay, so like I was saying, comparatively, and I laugh. I'm like, okay, fine. You know what? I'm always open for new shit. Because usually the guy will, how it gets kicked off is the guy will put up a picture of him testing a transistor. And he'll have a question about the transistor itself, right? And so what he'll put up on, you know, usually Fartbook is a picture of the transistor, a picture of the tester, and he's holding it up and he's pointing at something, right? And guys, inevitably, just to be dickbags, they'll pop up and go, well, you know, that transistor tester isn't very accurate. It's horrible. What? And so then the guy will come back and goes, what are you talking about? It's the one that's the exact same thing BBI uses. I use it because it's light, it's easy, and it's smart. You can hook all 3 leads up any way you want. It figures it out. And, you know, just going back 15 years ago, this thing was badass. They wanted a small fortune for it back then. They wanted like $190 for it. It's come down. This is like a $80 unit now. You don't have to figure out what base emitter collector is. It tests MOSFETs. It tests everything. It tests it and says, Worky, no worky, here's a base reference number. I don't care about the absolute max HFE gain. What I want to know is if I pull a transistor out of the amp, put it on a paper towel and measure it, and it says it's got a beta gain of 35, I can take this same tester, beta gain of 35, go find another used transistor, got beta gain of 35, and the two transistors have a close enough HFE gain that they don't rip each other's assholes out. That's really all we're doing. Okay. And so then as soon as the guy says, well, this is good enough for BBI, damn skippy it is, there's always some, I call it keyboard warriors, you know, flaming gonads of the universe. Well, let me just educate you about something there, is how they usually, the keyboard warrior rolls back. That guy, blah, 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 blah. And that Atlas is shit. Actually, the Atlas is great. And so I usually show up, I'll read the whole thread, let it go through its whole arc of creation, attention, comments, and then wait for the thread to almost end, and I'll come along and be like, okay, well, I'm open for input. Show me a transistor tester that is in the exact same price range, and that's from the $50 to the $125 range, that is either as accurate or more accurate, is as flexible, and is tests as many components. Oh, and it's also got to have a built-in curve trace software to it. And I always get crickets. I don't know if it's because I showed up to the conversation and they get intimidated, or that there's nothing else out there in the market that's in that price range that allows you to have as much flexibility with the amount of testing that that thing can do. The overall argument is that the transistor tester isn't super accurate, but it works well enough for us to be able to do high functional repairing with it, and it gives us a lot of flexibility, especially for somebody that doesn't want to spend $1,500 or $2,000 to check out their little transistors inside their amplifiers. Just saying. Or check 2N222s with it. You check everything with it. Just stop. Stop. Go cry to the masses on some other post about how you got dad issues because he didn't play softball enough with you in the backyard, or throw the ball around or some shit, or, you know, explain to us why you're still living in mom's basement other than trying to run around Facebook and look highly intelligent and enlightened because you know a little bit about transistor checkers. I would love to be able to just take the spotlight and turn it back around on those guys and be like, cool, show me your transistor checker and show us you working on stuff. Never happens. And I say that from the point of view of, I would love to see more people get in this game. I would love to see more people take on the passion and the love that is required to repair these things and put up with the public and have the stockpile component. I would love to see more people get in this business. There is not enough of us technicians. I wouldn't even consider myself a technician. I call myself a tinkerer. There's not enough of us in this industry to support the need to get the equipment repaired. There's just not. There's not. Everybody that's in this business is worth a pot damn is buried up their eyeballs in work. I know, because I hand off work to guys that are worth a shit all day long. You know, Hopper, buried. Tech 9, buried. 3, buried. Everybody, Fat Boy, buried. Carl Bill, buried. Everybody is worth a damn, completely covered up. I even heard something about 123 the other day come out and put a big post up that he's got too much work, he's got to not take any more on for a hot minute. Which is good. I applaud Denny, I think that's great. And I applaud all these other guys, because believe me, I tell people all the time, well, what part of the country are you in? Here, call this guy. He's way closer than me, and he's not going to be as buried as me. I hand off work, I give away fortunes. And I'm not even ashamed of it. I think it's great. We all should support each other, but it's not from that point of view. I'd love to see these guys flip their stuff around and be like, well, yeah, here's me, and here's my test equipment, and this is what I do, and this is my business. How can I help people? And then maybe from out of all of that, we'd get 1 or 2 more technicians up in this game. Just saying. Just saying. But it's hard to find the guy that doesn't have that big ass ego. I'm telling you. If If you got to run other people down to make your business look better, you're not really any good at your job. That's all I'm going to say. I'm talking shit about nobody and not pointing no fingers at no one. I'm just saying that the overall consensus is if you've got to run other people down continuously, either it be through YouTube or Facebook, to make your business look good, you're probably not that good at your job, because look at where I sit and I've never said a negative thing about nobody. Except for one guy. He was building amplifiers, AC amplifiers that were so dangerous it was, well, it put one dude in the hospital and almost killed another. So anyhow, let's move on. Let's go back to this dumpster fire and let's get it finished. I was just on the phone with you, cue ball. We're talking about antennas for a hot minute. And I couldn't bring myself to tell you I was working on your box. Okay, so I went and I rebuilt this a little bit. I just kind of replaced the green solid core wire, soldered stuff down to the board. I had all the output RF moving through this little tiny piece of wire. Down here I upgraded that to 3 times the gauge and actually made it stranded so it'll hold. Replaced this giant 50 volt electrolytic and replaced it with the appropriate capacitor. Now I got to come up here and I'm going to change out the preamp transistor. I'm going to replace this resistor. Shoot, where'd it go? With this new one. It's flame resistant, and this looks burned, but that's actually a shadow. And then I'm going to start putting transistors back in this thing. I went ahead and put our workaround in from here to here, so now we'll have full relay action, but pills are out and most of the burned up parts are replaced. We're going to use a Toshiba 2290 and we're going to drive 4 HG 2879 16 D08s. But this thing's still going to do right around 500 watts, probably 550 watts, somewhere there. I got to add a bunch of parts here to the driver's section that we're missing. I got to rebuild this whole butt nugget section over here in the corner. But yeah, I just want to show you where we were at before I started really moving along. This is looking more like a livable thing. Like I can say, okay, I was in here and love you, dude. Whole day. I'm going to spend a whole day on this box for you, brother. Okay, the hard part's over with. It's got 5 brand new transistors in it. The 1 pill section was completely built wrong. Had the capacitance on the wrong side, missing the 1000 puff capacitor down here. The way they had the transistor hooked up was all wrong. The 230 was actually on the output and it needed to be, this needed to be here and not here. This cap shouldn't have been here, it needs to be here. That cap wasn't hooked up and this one was broken off. The biggest problem I've had so far on working with this box is when something gets burned up this many times and there's so many technicians with their fingers in the pie, you go and you touch stuff and the traces come off the board. Dynamic pain in the ass. Now, the hard part is physically hard part, like trying to get the soldering irons in here to build all of this and get all this put in the right place, is done. These are supposed to be, I think, 34 ohm resistors, 39 ohm resistors, whatever. I'm going to use hundreds, it doesn't matter that much. Just a dumpster fire. This whole section, once I took it all apart, everything underneath it was all burned up too. This thing has been smoked a couple times. Like the bias link that goes here, and really what stabilizes this transistor is this bias bar. When I went down in here to unsolder it, there was 3 cut off legs of resistors that were bias resistors that people have put in there from time to time. The bias resistor that was in there doesn't read as anything. It's completely open. There's no conductivity through this resistor at all. So went ahead and replaced it with a brand new 1.8 ohm resistor. Upgraded the preamp transistor. Now it's all the finicky shit. You know, I gotta put power wire in it, and I want to upgrade the coax. But remember, we've already washed this once, and I gotta wash it one more time. And this time I'm gonna use something a little bit more aggressive, like acetone. I just gotta be careful where I put it on a board. Like I can't get it around any of the switches. I'll probably, since it's so easy to remove the relay cover, I just gotta be careful I don't get it on the relay. Otherwise it'll make the plastic soft and it'll smoke out the plastic. But the bias is right, the bias to switch, the resistors are right, everything's going to the right place. Now the $64 million question is, because a lot of this stuff is through board, is I was soldering all this stuff on here, did I cause anything to drip from the top side of the board to the bottom side of the board? And what I mean about that is everything I've reworked here and everything I've reworked over here. We don't know. We're not going to know until we test it. And then the finicky stuff, like getting the lights to work. This stupid stuff. I mean, this stupid shit just to make the lights work, the indicator lights. Because if you remember, they were all real finicky. They were vibrating around. So I soldered these pins on the power on switch, and I soldered the preamp pins. I have not done these other two. It looks like the pins are all bent from being messed with before. There's a reason I said I didn't think it was worth getting into. Honestly, this has taken, we're in hour number 5.5 now. And it just, every single time I turn around, oh look, I gotta fix this too. Oh, and this isn't right either. So, I mean, in the long run, the customer's gonna get an amp that works and he's gonna be happy with it. Money-wise, you know, it's a constant balance, y'all. It's a constant balance over the cost of the box versus the cost of the repair. Okay. Being that this is a 500 watt box, I know that I could have built him easily in the same amount of time a completely custom 1x4, and it would have done a full 500 more watts. The repair on this is going to be, you know, $400 or $500. Why not spend $200 more and get a whole brand new box with all brand new parts in it, nothing that has been in here and burnt to death 5 times from Sunday? That's, I don't know. He's got some attachment to this thing. I don't know, but okay. I'm gonna go wash this with acetone, clean this up as best as I can. I mean, some of the stain is not gonna come out, but I want to wash it again to primarily make sure I got all the little solder flick out of it, because this thing's been apart so many times. Like when I washed it the first time, you should have seen all this shit just rolling out of it. I just used 91% rubbing alcohol and a little bit of Windex, and then come back and hit it with rubbing alcohol. The soap helps get rid of most of the dirt. The alcohol actually dissolves all the flux. And then I use the alcohol to rinse the soap off, if that makes any sense. And when I do that, it's stripping any moisture or any of the other bits in here that we don't want to have left over. We take that away. But it's not so aggressive like acetone to where it's going to smoke the plastic, melt the switches, damage the face, or damage the meter. But I'm going to go to that next level with it on the acetone here in just a second. So when we come back, the input and output coaxes will be replaced. It'll probably have new power wire in it and a very subtle, not subtle, but a very refined 12 volt power upgrade. So positive B plus upgrade. Oh, and I got to add a little piece of 12 gauge that goes from here to here on the board. Make sure everything's bonded at the same electrical potential. It's a way shorter distance than making the ground potential travel all the way to the next case screw, then down through the heat sink and then back up onto this board. So it's to help us cut out a ground isolation issue that can show up between the two boards, the front and the back pallet. So, okay. I want to get done with this before the sun goes down because I want to hop back onto the 24 pill I got to work on. Yeah, I'll be back. I just got to jump back in here real quick. I got the board to come back shiny. I can't believe it. I can't. That's unbelievable to me. We were able to get all the tinge off of this thing for the most part. There's some little areas like up here around the switches and the meter face that I didn't want to get the acetone too close to, but I mean, we're even able to get most of the burn. This is a lot of the burn has been removed from back over here in this corner. Yeah, the board's white, not black no more. So I just had to showcase that real quick. Okay, let's throw some power wires in this thing and change some coax. Let's get done. I really don't want to work on this anymore. All right. So this amp really was not worth repairing, to be honest. And I gotta go get the damn tin. It's outside in the sun drying. Hold on. The lid was solid rust. So I got out the old Scotch-Brite wheel, I sanded down to bare metal, primed it, and then put gloss black on it. And from when I touched it, it's got oil on it now, but this was all pitted and disgusting on the inside because this amp has obviously been freaking submerged underwater. I've spent the last almost 2 hours making it so the switches all work properly and the lights work. And I get those fixed and I put all new lenses on the front, and then I go to actually make sure that the meter works, and this meter is frozen, frostier than the woman that's been married for 60 years. Frozen. I mean, like, cold ass don't work no more. So got a brand new meter put in it. The problem is a lot of the pins on this thing were so badly corroded. I was having issues with traces. I was having issues with the pins and cold solder joints and trying to get the pins to take solder, even with flux, but not so much solder that the solder would drip through and short out on the bottom side of the board to the case and not damage the switches. Then all the little tab leads that make contact, the lights, the little clips that attach to the switches, are all held in with pressure, right? Well, because this amp has been submerged at some point or another, the surface area between the pressure tab and the pin is completely oxide. There's two differentiating metals that are now been wet, okay, and they just corroded. So I had to go in and clean all of that, and I soldered those to make them so they'd work reliably. It's just a lot of time. There's more time into trying to restore this amplifier than what it was really worth, by far, hands down. I was just on the phone with my buddy Zane. I was like, dude, if I hadn't been doing a surprise YouTube video for this guy, I would have taken these two boards out, and would have thrown 2 other boards out of a donor 667 in here, and have been done with this like 4 hours ago, 5 hours ago, 4 hours ago. It's 7 o'clock at night, and I started on this at 11 today. So 8 straight hours working on this guy to get it all running correctly. Power, preamp, dial-a-watt, sideband. You can't see it, but they are all working. Now we can see them. And yes, they're on upside down for a reason. Reasons. Now we're sitting at 12 volts. Let's turn on the power supply. And they're going to get a little bit brighter, but not much. So that's them in their brightest state of existence. All right, so now let's manually run the gain back down so we don't completely blow everybody's eyeballs. Okay, lights back on. So, needless to say, that's all functional. Let's widen up our shot a little bit. Let's go over here. And let's zoom in for a minute. Hey, cue ball. Next time Daddy BBI tells you that something's not worth fixing, don't change your mind a year later and say, hey, let's repair it anyhow. Because I will send it back. All right. There we go. Let's unflip all these switches. Hello, 1, 2, 1, 2, 1, 2. We're on the 2950 bench radio. Hello, 1, 2, 1, 2, 1, 2. 5-watt slug in reverse between the Texas Star 500, tx500, and the dummy load. So 1,000 watt slug in peak, 1,000 watt slug in average, of course. 5-watt slug in reverse back from the bird, 10,000 watt dummy load. So drive, hello, 1, 2. Remember, about 500 watts, right? Hello, there's 6, no problem. AM, hello, about 500, and now with the sideband delay. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. To come around and find out that this meter was frozen was like, are you freaking kidding me? Because the meters are silly expensive. They didn't used to be, but now they're crazy, stupid expensive. Hello, 1, 2, 1, 2, 1, 2. Okay. Hello, 1, 2. Hello, 1, 2. It's working. Not that anybody ever looks at those stupid things, but it is what it is. Hello, audio. Hello, audio. My point of view is doing about 590 watts. I think from your point of view, it's probably going to say about 580 watts. I don't know. And we've proven this many, many times. If we move the camera to the right or the left, it shows more or less because you're changing your angle of view. So, these are our big, shiny tin screws. We're able to get the tin to clean up relatively well all the way around. So this thing has been bathed in acetone and alcohol and Windex and everything else that we can possibly think of to make it look pretty and new again. I would say that this thing's probably been burned up at least 5 times. At least 5 times, and then it's been very wet. But the board isn't brown anymore. Like, this area isn't brown anymore. This isn't brown anymore. This isn't all scorched earth black. It's all working. Upgraded preamp. Everything's working. So now, why did I put the switch covers on upside down? Because I really want to put a fan on this, but I don't know if he wants a fan or not. Well, I'm going to put a fan on here, and if he doesn't want to have the fan on there, he can take the friggin' fan off. That's just my opinion. So, give me just a minute. And put a fan on this thing. I'm tired. I don't want to talk about this thing anymore. I'm sorry, man. The whole switch situation, that just was like, what in the hell? What next now, man? Okay, now we're ready. We're going to leave that last little bit in there, but we're going to pretend like we're going to start over. Ready? There's the logo. Okay. Honestly, the switch is just, it took forever to figure out. I'd get one switch working, and then the next one would quit. And then the only one that worked consistently the entire time is the SSB knob, the SSB switch. So this thing's done. It's Short of me pulling the heatsink off and having it chemically scrubbed and then re-anodized, I can't believe we got this thing working again, honestly, and balanced out. I mean, I can't. I'm just, My friend Cue Ball, we're going to see you in about 5 or 6 days. And in 5 or 6 days, I'm going to hand this to you, and you're going to be like, what the hell, really? I'm going to be like, yep. So I hope you've enjoyed your video, my man. It was a pleasure getting to work on yet another piece of equipment for you. I know that you got a couple more goodies for us to pick up while I'm down there, and yeah, we got some dealings to make. Gentlemen, on that note, I'm going to run away. I'm going to go do other things. I'm going to go back to working on this 24 pill for my buddy 300. And yeah, hope you've all enjoyed. Gentlemen, I'll see you. Bye.